Hello, everyone. Welcome to your Ponds GIS Lab. At this point, you have already seen a presentation about what GIS is and how it works. You've read through the introduction of this lab, and you have done step one, which means you've downloaded the data onto your desktop. If you are in a group and you are not the person actively working through ArcGIS, please just follow along with them, watch these videos simultaneously, and then offer support and assistance to the person that is clicking through ArcGIS, because it can be a little bit of an overwhelming system. There's a lot of buttons, as you'll see in a little bit. And when you're watching this video, feel free to pause at any time, rewind. The reason why I'm recording this video is so that you have the option of taking this at your own pace and referring to the steps that I show you, as well as the instructions for when you're not actually in person with me in class. So we are going to start with step 2, start ArcMap. So I have BB Learn open right now, but it doesn't matter which kind of background apps you have open on your computer. What you'll want to do is, if you're working on a PC, you'll want to go down to type here to search. This may look like just a search bar like I have here on my computer, or it may look like a circle like this. Any way that you can find the apps on your computer, you're going to want to search there. And you're going to want to type in ArcMap. For those of you who have downloaded ArcGIS onto your computer before class, I hope that you made sure to download ArcMap, not ArcGIS Pro or ArcWorld or something like that. And if you have those other options already downloaded on your computer, we're not going to use them today. The instructions for this lab are in ArcMap, which is the kind of baseline ArcGIS tool for the desktop. So you'll want to go and click on ArcMap to open it, and it will take a little bit of time to open, so don't panic. It's a really big program, so it takes a little while to load. And great, so when it opens, you're going to get a getting started window that pops up. You're going to want to open a blank map. So as you can see for me, the first screen has a blank map option right here. If you don't see this blank map, you'll want to go over to this legend on the side and click on new maps. And then you'll just want to click on the very first one, which should be blank map. So now you're just opening a brand new map that has nothing in it. And it's a really great blank canvas for us to start on. So we're going to go some like basics in ArcGIS. This button right here, it's like a little yellow square with a plus sign on it. It says add data. This is where you're going to go to add everything that you've downloaded from BB Learn, like all of the data that we've given you, into your map. Something that important to keep in mind, like if I hover over this icon, this whole rectangle lights up in blue, both the icon itself and the little arrow next to it. So when you go to add data, be sure to click on this little arrow, because this will give you a bunch more options rather than just adding blank data. Something else to keep in mind is if you go over to the right here, you'll see your ArcMap catalog or your ArcGIS catalog, and this has a bunch of data analysis tools in it that we'll be able to use in our lab today. So that's a really helpful thing to have. If you can't find this catalog, as you can see, like there's this little icon here. If you don't have catalog stuck to the side of your search bar of your ArcMap here, like see it's gone now. I can just go back over here to catalog. See this, it has, I'm not really sure what that is. I think it's a filing cabinet, but you'll click on that little filing cabinet icon and it'll pop right back up. If you want it to hide, you can click this little pin and it says auto hide. So those are some of the basics. The very first thing we should do is to save our document. ArcMap is really great at shutting down because it is such a big program and there is so much data being stored here that sometimes it can't handle the amount of processing that it's doing, and it just aborts itself. So it's really important that once you get to a point that you like and you're feeling confident with, save as much as you can, save frequently and saved often. So we're going to go to File and Save As, and you can name this whatever you'd like, and you can save it to wherever you like. I'm just going to save it to my desktop, and I'm going to call it Ponds GIS Lab. and save. And I'd recommend after you do each task to just click this save button here, and that will really help you make sure that you don't lose anything in your process. So we're going to go ahead and add some data. So we're at the fourth part of step 2. So we're going to go up here to this add data button. It's our best friend in today's lab. And we're going to just go to add data. And now, as you can see here, we have a bunch of these options for where our data might be stored. The very first thing we want to do is we want to connect to a folder. And the reason why we want to do this is so that every time we add the data, like we have a bunch of different data that we want to add to this project. And so we want to not have to like navigate through our entire computer to find the data every single time we want to add something new. So we're going to connect to the folder that we downloaded from BBLM that has all the data in it. So you'll go ahead and click on this little icon. It's like a file folder with a plus sign on it. And you'll want to find the file where you saved all of your GIS data for this lab. So as you can see here, like I have this GIS data, but it's a compressed version. So you don't want to use that one. You want to use the one that's been decompressed already, which is this one for me. And the way I can tell that is this one has a little zipper on it. So if you see a zipper on the file you want to use, don't use that one. It won't work. Make sure that you connect to the one that has no zipper on that icon. Something else to keep in mind is, as you can see, like when I click on that main folder, there's a bunch of subfolders that pop up. Make sure you select one of these top main folders. Don't select one of these bottom folders because then you'll get a little bit lost. So just highlight one of these main folders, ENV 171 Pond GIS data in blue, and then click OK. And so now every time we open this add data button, it will open up with our data inside. So we are going to step 3, part 1, which is where we are going to add the geology folders. So you'll go into your Ponds GIS Data Lab and go within geology. And then you can see all of these different files here. There's the border of Arizona, there's a geology layer, the different ponds layer, and our study area. And as you can see, they're all called .shp, which means shapefile. And that's one of the main file formats that we can use in GIS. So you're going to click Shift. You're going to click on one of these items, and you're going to click Shift, and then select the bottom item. So the way that you select multiple items is to click on one of them, hold down the Shift key, and then click on the farthest away from that, and you'll click so that all of them are selected, and you'll click Add, and that will add all of them to your map. It'll take a little bit to add, so just be patient. And as you can see for me, all of these layers have been added here. So we have this really helpful table of contents, which just kind of lists all of the layers that we have on our map. Your colors might look different from mine, and that's totally okay. Every time ArcGIS opens a new file, it opens it with a different color scheme. It's just random, so it's okay if it looks different. And like I said before, I'm just going to go ahead and save this just so that I don't have to re-upload that data. Some helpful things to know about layers is that you can move them around. It kind of works like one of those pop-out books where something on the top layer is going to be closer to you, and then something at the bottom of this list is going to be farther away from you. So for example, I can drag this up to the top, and now my study area icon is at the top of my map. And for example, if I wanted my border to be on top, I could drag that to the top, and now you can't see anything below it because this one is filled in and it's at the surface. So I'm just going to go ahead and drag that one down to the bottom because we don't need that one just yet. Another really helpful thing to know about this table of contents is that you can deselect different layers to make them invisible on your screen. They're still going to be uploaded, like they're still available to me. I can always recheck them and have them pop up again, but it's really helpful just for visualizations and for speed of rendering. So like, for example, if I had all of these layers up and if I had 20 more layers, it might take, like 10 minutes for me to zoom in to a section. But if I turned, the layers I didn't need off and then I zoomed in, it would go a lot faster. So just keep that in mind as you're going through this lab, that you have the ability to move things around and to turn layers on and off. So now going back to the instructions, we've done number 1, which is using the add data button, add the 4 shape files inside the geology folder to the map. We can see the outlines for both the state of Arizona, which is my purple one here, and the study area where we have all of our ponds. So this is kind of the area where all of the ponds in this data set have been located. So as you can see, if I turn them on and turn off the study area, all of them are just kind of confined into this little rectangle. So we're going to click on this Arizona border box in this layers list, and we're going to make it so that it's just an outline. We don't want any of this purple fill. So to do that, we're on step 3, number 3. We're going to change the symbol of this to hollow, so it's just an outline. So to change the symbol like this, all you have to do is double click on that purple little square underneath Arizona border. And as you can see, currently it says fill color here on the kind of right-hand side. So you just want to go and you'll want to change that to no color. So you want fill color to be nothing, and you'll click OK. And just like that, there's no color in my border of Arizona. So now we are going to try and get a better sense of where our study area is. And so to do that, we're going to add a base map, which is essentially a map of the world, just like Google Maps, that comes with ArcMap. So to do that, you'll go back up to this add data button, but you'll make sure to click on this little arrow to the side of it, and you will go down to add base map. And you'll see there's a bunch of different options that will pop up. For the purposes of this lab, we are going to add the topographic map, but you're more than welcome to explore all of these different types of maps. And especially if you have decided to download GIS and would like to use it in your future, some of them are more useful for some types of projects than others. And they're all really neat to see how different maps portray the same area. So we're going to click on topographic, and you're going to click add. And it might take a little bit to add because you're adding a map of the entire world. So just be patient for it to render. All right, and then if you come up with a warning box like this, you can just say close. And hardware acceleration, you can just say yes or no. It doesn't really matter for this. But now we have this really helpful map of the whole world. If you were to zoom out, you could see all of the world. You can zoom in and it will change the resolution as you zoom in and zoom out, which is super useful. So now we're going to zoom into our study area. So another really useful tool is this zoom in tool. I like to click on the tool and then I just drag a box around where I want to zoom into. So you click on that little magnifying glass with a plus sign, and then you just drag a box around the study area. So around where all the points are, and release. So as you saw, when we zoomed in, all of these points got a lot smaller so that we could actually see like it changed with the scale of the map. Once you click on the zoom in button and you're already in the zoomed area that you're ready to use, make sure you click back on this hand button, because otherwise if you still have the magnifying glass selected, you'll start zooming into all these different areas and it will get quite confusing. Another really helpful way that you can zoom in at any point, if you get lost or if you get confused, you can right click on whichever layer you want to zoom into. So for example, like I'm working with these ponds, I want to see where they are. I can right click on ponds, and then I can go to zoom to layer, and that will bring me right back into the exact layer that I want to work with. So now we want to highlight our study area, and we want to change this to a hollow as well. So you're going to click on this little rectangle, this blue rectangle or whatever color it is on your map under study area, and you're going to change that to hollow. So fill that with no color as well. So that way we have this nice border around all of our points. So now we're on step 3, number 6. So you want to make sure that the ponds layer is above the geology layer, which I have here. So if it's not, you can go ahead and drag your ponds layer above the geology layer so that we can see both of these. If we had the geology layer on and it was above our ponds, we would not be able to see both. So we want to make sure that our ponds layer is above the geology layer. Okay, so now we are going to change the symbology of our ponds and our geology layers. So at this point, all we know is that there's a bunch of different ponds on a landscape. As you can see in this geology layer, there's like all these different blobs here. Each blob represents a different type of soil or a different type of substrate, but we don't know what that means yet. Like all of them look the same. If we were to have a legend for this map, we would assume that all of these rock types are the same because they're all the same color. And the same goes for the ponds. As you talked about in lecture, every pond in Arizona is either an ephemeral pond or a permanent pond, meaning that there's either water in the pond all the time or only water in the pond sometimes. But at this point, because all the ponds are the same kind of brownish maroon color, we couldn't really tell which is which. So to do that, we need to change the way the symbols look, or the symbology. So to change the symbology, you'll go up to the layer you want to work with. So the step 3, part 7 is working with this ponds layer. You'll double click on that layer. So make sure not to right click, only double click on the name of the layer. And then after a couple of minutes, it will pop up with this really great layer properties window. So you'll have some general information about your layer, and it will help you with some more advanced working around with that layer if you so choose at a different time. But today we are going to go to this symbology tab, and we are going to go to categories. And essentially what this does is it splits up the way our points look into their different categories. So you'll want to click on categories here in this little legend. You'll go to unique values, and then for your value field, you'll want to select hydroperiod. And hydroperiod essentially just means how much water is there in an area across the year. Is there water in there all the time? Is there water in there not very often, or is it kind of in the middle? So once you select hydroperiod for your value field, you'll go down here and you'll click add all values. And as you can see, we have these 3 options. We have permanent, which is water all the time. We have ephemeral wet, which means there's water in there sometimes. Sometimes it's dry, but most of the time it's wet. And then we have ephemeral dry, which means that there is water sometimes, but rarely. So now that you have these 3 options selected, you're going to go up here to color ramp, and you'll just choose whichever one you like best. I'd recommend choosing one that makes it so that all 3 of these colors of these icons that you see here look very different. It is possible that you choose one that makes them look like kind of similar, which might be a little bit confusing later on. So just go ahead and look through these and try to choose one that you think best reflects your data. So I'm going to go ahead and go with this one because I think these colors are pretty straightforward and I can tell the differences. So then once you have that chosen, you'll click OK. And just like that, we have all of our ponds reflected differently. So as you can see, there's a lot of ponds that are this yellow color, which is ephemeral wet. This red color here are my permanent ponds, and then my ephemeral dry ponds are my green ones. I'm going to go ahead and save at this point. And now we are going to learn a little bit more about our ponds layer. So we are going to right click on this ponds layer, and we're going to go to attribute table. So I'm on step 3, number 8 now. And we're going to click on open attribute table. And as you can see, it's just like this little spreadsheet that tells us all of the information that is stored about each of our points. So we have the shape, which is a point, obviously, because it was just all these are points. They're not lines and they're not polygons like this other layer back here. These are all freshwater ponds. I believe they all should be ponds in this data set. You have the acreage, or how like the acreage of the pond itself. You also have the hydro period. So it's either ephemeral, permanent, or like ephemeral wet. And you have the elevation where that pond is located at. So once you're done looking at that, you can go ahead and click this X and close out of it. Now we're on number 9, change the symbology of the geology layer so that the different rock types have different colors. So once again, we're going to double click on this geology layer. And we're going to go to our symbology tab. We'll cruise over here to choose categories, unique values. But this time for our value field, we'll choose rock type 1. And we'll click add all values. And I'm once again going to change my color ramp. I'm going to change this to something that looks like rocks. You can change it to whatever you'd like, but I like making my maps reflect what they are. So these all look like different rock types, and I think that's fine, and I will click OK. And so now we have a map that shows us all of our different rock types and all of our different ponds. So as you can see, there's this red kind of color, which is limestone. We have this kind of yellowy color, which is basalt, which makes sense because we're here in Arizona. We're near the Grand Canyon, which has, due to uplift, we have a lot of limestone, which is a rock made from deep sea sediments that got uplifted over time. But we also have a lot of this like volcanic basalt in here from all of these volcanoes that we live near. So this makes sense to me. I'm going to save that. And so with your group, if you're in a group, I'd like you to take a couple of minutes, pause the video, and discuss if you see any trends here. Do you see any relationship between the type of ponds and the type of substrate or the type of geology? Are there trends? Are there more ponds in one geology type than another? Are there different types of ponds in one geology type or another, and why? So take a couple minutes, pause here, and discuss with your group. So now that you've kind of worked through that hypothesis with your group, we are going to move to step 4 for groundwater. So we're going to uncheck this box next to geology. And we are now going to work with a different type of data. So we've answered our geology hypothesis. And now we're moving on to groundwater. So this hypothesis is asking, does the amount of groundwater in an area determine whether a pond is permanent, whether that pond is ephemeral, or kind of somewhere in between? So we're going to go back up to this add data button. We're going to go to add data. And we're still in our geology folder, which won't help us. We need to get to a different folder to access our springs. So we're going to use this little up arrow that says up 1 level. You'll go ahead and click on that. And we're back in our main folder, our GIS ponds data. And you can see we have our geology folder, which we just used, but now we're going to go into springs. So you'll double click on the springs folder and you will add this springs shapefile to the map. And as you can see, it has added a bunch of these purple points. So these are springs where groundwater is coming out of the ground. It's no longer in the ground. It's kind of being emerged and brought up to the surface at all of these points. So because the springs are only one type of data, they're not like, you know, dry springs or wet springs, they're all just springs. We can leave them as one type of point, but in my opinion, it's kind of hard to distinguish them from these green points. So I'm going to double click or click on this little icon here, and I'm just going to change it to something that makes a little bit more sense. So like I might change it to a circle. I might change the size around, and I'm going to make them blue just so that I can see it a little better. And I'll click OK. So you're welcome to change it to whatever color you'd like, whatever shape. Just make sure that you can distinguish these springs from the other points that you have that represent your ponds. So as you can see here, we have these big old clumps of springs in different areas, and in some areas we have no springs. You're welcome to turn back on your geology layer and see if there's any trends that way. Yeah, so now we are on step 4, part 3. Notice that the springs are not distributed evenly across the landscape. There are some parts of the study area that seem to have a lot more groundwater coming to the surface than others. So number 4, to quantify this, we are going to calculate the density of these springs across the study region. So that we have enough information for the entire region, we will create a raster file where each pixel holds an estimate of spring density. So this is where the power of GIS lives. It's in this data analysis. So we are going to essentially make a picture that will tell us, based on the color of that picture, where there are areas of lots of springs and where there are areas of not so many springs. Because for some areas, like right here, there's a few springs, but I don't know how much there are in this area compared to, like, say, this area. Does this area have more or fewer than this area? So this will be really helpful to tell us information about those in between areas that have like a medium amount of springs. So we're now on number 5. We're going to make sure that our analysis tools are turned on and ready to use. So we're going to go up here to this customize menu at the top. And we're going to click on, once it opens, we're going to click on extensions. So you go ahead and go to customize and then click extensions. And you'll get this little window that opens. And you're going to want to make sure that your spatial analyst toolset has this little check box next to it. So you're going to turn on all of these tools. And this is just allowing us to, like, because GIS is so big, it sometimes hides these larger tool sets so that it doesn't bog down the system. But because we're using tools within this toolbox, we want to make sure it's turned on and available to us. So make sure that has a little checkbox, and you'll click close. And now we are going to go to our ARC toolbox. So if you go up to this little toolbar here, you'll see this icon with this little red toolbox on it. You're just going to click on that. And it pops up with this toolbox. What I like to do is I like to drag it to this little blue button on the side here so that it like stores it on the side of the window and it's not floating in the middle of my workspace. But you're welcome to keep it where you want or move it wherever you want. It's up to you. So within this toolbox, we have a bunch of sub toolboxes. These are all super powerful data management tools. We'll only be using a few of them today. So the first thing we are going to do is we are going to go into our spatial analyst tools. You're going to just click this little plus sign next to it, and it opens up a bunch of different tool options. So we are going to go to this one here that says density. You can either double click or you can click on this little plus sign. And then we are going to go to point density. You're going to go ahead and double click on this point density tool. And you know that it will open its own little window because it has a little hammer here and not a toolbox. So now within this little window, we are going to essentially tell ArcMap which of these layers should it use to determine the density of points in an area. So for this input feature, this is the feature that we are going to let our GIS determine density based on. We're going to use springs because we're trying to figure out the density of springs in an area. So you're going to click on this little down arrow here, and then you're going to click on springs. And after a little bit of time, it should work for you. For population field, you're going to click on this down arrow and you will click on none. And as you could see, there was a little error there, but now that we chose none, the error is gone. And because we are not summarizing any information about these springs other than their location, that's why we've chose none. And then for our output raster, this is just kind of the name and the location of the picture that it will create of the density of our points. So we are going to click on this folder icon here on the side. This will tell us where we want our file that we're creating to be saved. And then we are going to find our folder where everything is stored. So I'm going to put it in my ENB 171 Ponds GIS data, and then go within there and just store it wherever I want in here. So I'm going to call this SP_DEN_10 kilometers, which essentially means spring density at a radius of 10 kilometers. And I'll go ahead and click save. And now our radius here, we are going to change that to 10,000. And I'm going to click OK. And so as you can see here, my tool ran successfully. I got this little green check mark, and it automatically put it on top of my map. So at this point, I can't see it because it's hiding under my geology layer. But if I turn off the geology layer, I now have this really useful map that shows me areas where there's higher density of springs and areas where there's lower density of springs. And I can use my legend here to figure out, I mean, we can kind of tell based on where there's more points where the higher density is, but we can also use our handy legend here if we didn't have these points available to us to see where there were more springs and where there were fewer springs. So like, for example, this darker color has 0.33 springs per 10 kilometers, whereas this lighter area has between 0 and 0.04 springs in any given 10 kilometer area. So now that we have a new raster that shows areas where there are more or fewer springs per square kilometer, we just want to make sure that this is in the right area. So like I said, I turned off the geology layer. You can also drag it to a different place if you'd like. If it's above your springs, like if it lives up here, make sure that you just drag it to an area that's below your ponds and your springs so that you can see all of them on top. So with your group, you'll take another couple of minutes and looking at this just based on visuals, does the density of springs seem to explain where we might find permanent ponds in the landscapes? So take a couple of minutes, pause the video, and discuss that with your group. All right, so now once you have come back, we are on to step 5. And step 5 is going to be looking at the drainage network. So now we will use information about the shape and the elevation of the landscape to figure out how water flows across the landscape, possibly ending up in ponds and possibly not in other ponds. So the basic steps are that for every little pixel on this landscape, so like if you can see here, I don't know, for those of you who are familiar with the game Minecraft, like all of these edges are very blocky, just like in that game. Each of these little squares is called a pixel. And so for every small pixel of this landscape, we are going to figure out which direction is downhill for that area. And so this is kind of showing us where water would flow. So if we have all of these springs, we don't necessarily, this is where water is coming out of the ground, but we don't know in what direction that water is going to go once it comes out of the ground. And that could have an impact on whether or not our springs have water in it all the time or not. And so for every pixel on this landscape, we're going to count up how many squares are uphill above it and would drain to that area. So we're kind of going to be making something that looks like a river system. These steps actually take quite a bit of time for your computer to perform. So to learn the process, we're going to practice with a small amount of area, and then we're just going to add in the bigger layer after. So to practice with a small area, we're going to go up here to this add data button. Once again, we're going to go to add data. And we're still in the, we were in the springs folder where we added that shape file for the springs. So we're going to go back up a layer, and we're going to go now into our flow folder. And we have all of these kind of different looking files here. These are no longer shape files. These are rasters. So these are kind of like the same thing that we created with this density layer. These are all like pictures of data. So we're going to upload the one that says DEM smaller, DEM smaller, which essentially means digital elevation model. So this is going to show us the elevation of the land, and we're going to add that in. And we can go ahead and we can turn off our spring density if we want. So now we have this really cool elevation model. And as you can see here, areas of high elevation are kind of white, and areas of low elevation are kind of black. So you can kind of get a visual, like imagine if you were flying in an airplane, you'd be able to see some mountains maybe here and some lowlands here. We're now going to go back into our ARC toolbox. So we're in step 5, number 4 on our instructions. And we're going to go back into our spatial analyst tools. And we're going to go this time into hydrology, because we're now dealing with water. And we're going to go to flow direction. So you'll double click on this tool, and once again, it will come up with a pop-up box. For the input raster this time, we are going to choose our DEM smaller, our digital elevation model that we're working with. And for our output raster, we're once again going to click on this little folder with an arrow coming out of it so that it knows where we want to store everything. And I can tell that I'm in the folder I want it in. It says my folder name here, which is great. So I don't need to navigate anywhere else. If yours looks different, you should navigate back to the folder that you stored everything in by using this up one level button. I'm going to look at my instructions, and I'm going to call this flow dir, which essentially means flow direction. I'm going to click save, and I'm going to leave all of the rest of these blank, and I'm going to click OK. And as you can see here, I know that my tool is working because it has this this blue kind of working symbol here. And I know that it worked because it gave me this pop-up window that says flow direction with a green check mark. And as you can see, it came up with this crazy flow direction thing. So I'm going to zoom into it. And I'm going to save my work. And this doesn't really tell us much. This essentially is just telling us what way is each of these slopes facing. So it's telling us, like, for example, maybe this blue is a south-facing slope and this purple is a north-facing slope, or vice versa. I couldn't really tell you because we're in the middle of a process. So this part doesn't really matter. We're now going to move into our flow accumulation, which will take this direction of each slope and will make it into kind of a river basin where it will tell us how much water is accumulating in each place. So we're going to go back to our toolbox, and we're going to go back to our spatial analyst tools, back under hydrology. And this time we're going to choose flow accumulation. So you'll double click on flow accumulation. And for this input raster, now we want to just use the one that we've just made, which essentially tells us the slope and how much water is on each slope. So we called that flow dir. If you named it something different, just use the one that you called it. But if you followed the instructions for the lab, we called it flow direction. And then for the output raster, we're going to once again click on this little folder with the arrow. we're going to make sure that we're back in our Pond GIS data folder, and we are going to name this flow ACC for flow accumulation and click save. You can leave the rest of the options the same, and then you will click OK. And as you can see down here, mine is working. And now we've made a new raster, which essentially shows us information about flow accumulation. Each pixel says how many total other pixels flow into that one. So here, my areas of high flow accumulation are white, and my areas of low flow accumulation are black. So we're going to uncheck the rest of these just to make our content work a little bit easier, because it's a lot of data to store. And we're going to change the symbology of this raster. So now we're in step 5, number 6. So to improve the display of this flow accumulation raster, we are going to double click on Flow ACC to get back to that symbology tab. And we are going to go to symbology. And this time we are going to go to classified for our option in this legend here. We're going to pick a color ramp that is lighter for low numbers and darker for high numbers. So for example, I might choose this one. So my low numbers are light and my high numbers are dark. Go here to classes and you will choose 10. And then you're going to click classify, which is right here next to classes. When you're in those classes, you are going to go to classification method. So this here says method, it's a drop-down menu. You'll click quantile, which essentially splits up the data equally based on how much data is stored for each level. And you're going to click OK. And then you're going to click OK again. And now you can see it's a little bit easier to see. We have our areas of low water, which are these light areas, which more or less are probably on like the tops of hills and ridges. And then we have what looks like a river system where all of the water is accumulating. We're going to go ahead and click save. And now that we've done this, we now know the process for what it would take to do the whole thing for the entire study area. So I'm going to go ahead and unclick my raster that I just made. And I'm going to go up here to my add data button. And I'm going to add this flow accumulation full.tiff file. And I can right click on that and click zoom to layer. So I'm going to go ahead and go to the thing I just uploaded, flow accumulation full, and right click zoom to layer, which will zoom me out. And now I have this giant layer of flow accumulation. You are welcome to go ahead and experiment with the symbology. So you'll double click on that layer and you will change around the symbology of this to make it something that's more visually understandable. You do not have to do this. Like I'm going to show you doing what we just did using the same steps. It might not make that big of a difference because there's so much data in this layer, it just gets kind of jumbled. So as you can see, you can't really see like where the rivers are, but the data is still there, which is okay. So you're welcome to take some time, especially if this is the hypothesis you want to work with, you're welcome to take some time and try to make this into a color ramp that is a little bit more visually appealing. If not, we are going to go on to step 6. How do surface flow or spring density affect pond permanence? So now that we've done all this data analysis, it's time for the exciting part. We're now going to take the information from these rasters, from the spring density one and the flow accumulation one that we've just made, and we're going to extract that information for each of the specific pond locations where the ponds are. So In ARC Toolbox, we're going to go to Spatial Analyst, where we've been working this whole time. We're going to go to Extraction, which is this one here, and extract multi-values to points. You'll go ahead and double click on that. And for the input features, we are going to click ponds. And for the input raster, we are going to choose both the flow accumulation full, and you're going to go back here and click this again, and you will choose spring density. Under output field name, which is this here, you're going to change this one to flow and this one to springs. And essentially what this is going to do is it's going to take information from these two rasters that we made, this flow accumulation one here and the spring density one. And for every point that has, like every pond point, it's going to take some of the data from these rasters and attach it to that spreadsheet that we saw for the ponds data. So click OK, and that will run. Might take a little bit of time. As you can see, it's running down here. And it worked, but I can't see anything that's changed. And the reason that I can't see anything change is because everything that happened was behind the scenes. It essentially just added a bunch of new data to my springs points. So to check this, I'm now on step 6, number 2. We're going to open the attribute table for the ponds data again. So I'm just going to right click on the name of the ponds data and go to open attribute table to make sure that this worked. So if I expand it, I now have a column that says flow and a column that says springs, which is great. So this is the spring density, and this is how much flow has been accumulated in an area. So on the top left part of the attribute table, we're going to go to, let's see, table options. So I've clicked on this little arrow next to table options, and I'm going to go down here to export. And so this is going to be making this little spreadsheet here into an Excel spreadsheet that we can work with. So we are going to export all of our records. We are going to click this little folder button once again, and we are going to save it into that same folder, but we want to change the name of it to like something like pond GIS results. And this is super important. You're going to save it as a text file. So make sure that you save as type text file. Do not choose file in personal geodatabase tables. Make sure you choose text file. Once you've done that, you'll click save. And then you are going to click OK. And it's exporting that as a as a text file to your folder, and you do not need to add it to your map. So when it asks you this, if it asks you this, say no. And so now you can go on to Excel. You are done with GIS at this point. You will come back to this at the end of lab. But that's just kind of to make your optional maps at the end. We now have all the data we needed to create our charts in Excel. So you are going to now make sure that you refer back to the instructions. Make sure that you follow all of the instructions kind of very straightforwardly, because uploading a text file to Excel can be a little bit complicated. So make sure you do read through all those instructions and follow them deliberately. If you have any questions about step 7 and step 8 for this lab, feel free to let me know and to ask me. A reminder that there are some different grading criteria for this lab. There's a paragraph that you need to write. There are your graphs that you need to have. And so all of you need to have those things independently. And then your map is worth up to 10 points of extra credit. So if you go through all of step 8, and you hit all of those points and you make a really great map that is shared with your group, you will get up to 10 points of extra credit. Those 10 points will be based off of the different map elements. And if you have everything and it looks nice, you'll have all those full 10 points of extra credit. So go forth. Let me know if you have any questions. And great job getting through GIS.